Okay, the last part in this course is talking about triple integration. Instead of talking, or instead of dealing with what with integral in two spaces, in two-dimensional space, now we're going to use what to integrate in three dimension. So instead of talking about dA, now we'll introduce what dV. dV is what the volume element. So dV as the volume element is what is the any combination of what dx, dy, dz. So it's dx, dy, dz, or dy, dx, dz, or maybe dy, dz, dx, dz, dy, dx, or dx, dz, dx, dy. All of these elements represent what the volume element. The volume element. What do you mean by volume element? It's like if this is the shape, not necessarily a cube, maybe a sphere, maybe any cube, any solid in three spaces. So if you have this solid in three spaces, dx, dy, dz is what is the volume element. This is dx, this is dy, and this is dz. So we will form what? A small cube here. The volume of this cube is dV. The volume of this cube is dV. So one will think about what dx times dy times the height, which is dz. Maybe one will take the base to be this, the side or the surface which face us, which is what dx dz times the height will be dy. So something like that. So this cube has a volume equals to what? To dV. The length for this cube is dx. This is dx. This one is dy. And the height for this cube is dV. I'm sorry, dz. So this is why dV has one of these forms. Now, as we did in what for double integration, we started with what? With constant limits. If the limits for x, y, and z, yes, not the volume, Fatima, dV is the volume element. Okay, V is the volume. So V represents the volume. dV represents what? The volume element. Of course, if you triple integrate over Q 1 dV, you will end up with what? With the volume. This is very important relation. If you want to find the volume for what? For a solid, just what? Integrate 1 dV. 1 dV will give you what? Will give you the volume of the solid. Now going back to if we have constant limits for x between A and B, y from C to D, z from R to S, and we want to integrate to find this integration. How to do that? In this case, when the limits are constant, you have the freedom to what? To switch the order for what? For these limits. So maybe one of you would not like to start with dx, for example. Maybe she wish to integrate first dz. She can do that. She can switch between what? Between the limits. So let us evaluate an integral using what? Using constant limits. Let us try to what? To interchange the limits or switch limits and prove that the integral, the final result for what? For the integral are the same. The final. So let us integrate, for example, let us choose dz, dy, dx. Let's start with dz, dy, dx. So in this case, you need first to assign the limits for z. So the inner integral goes to what? To z. dz from 0 to pi. dy from 0 to 1. dx from 1 to 2. To x e to the power y Now start with the first integral. Now, oh, sorry. Any constant. Yes, you're right, Father. So any constant, any expression, any term which does not depend on z will be what? Will be factor out the first integral. So dz sine z stays, and we pull these out of the first integral. And now find this integral. Find integration from 0 to 1 for sine z. Sine z minus cosine z from 0 to pi. From 0 to pi, this is what? 1 minus, which means 2. 2 can be go what outside what the integral with the other 2. So 4 outside Now we have double integration. As you see, we reduced the triple integration into what? Into double integration. Now, let us what? Evaluate the inner integral with respect to y. Yes, the exponential stays, and we pull x outside. Now you need to integrate this integral. This integral, the antiderivative of e to the power y is again e to the power y. E to the power y from 0 to 1. So e minus 1, yes. So this is 4 times e minus 1 times the integral from 1 to 2 x dx. And the final step to evaluate this integral. The integral for x is x squared over 2. X squared over 2 from 1 to 2. So 4 squared over 2, 2 squared, I'm sorry, 4 over 2, 2 minus half. So 3 over 2. 3 over 2 times 4, so 6. So this is the final answer of this what? Of this integral. Remember this answer, 6 times e minus 1. Now, could you please take like 4 minutes, 5 minutes to evaluate, change the order. Change the order of this integral. So the final answer was 6 times e minus 1. So now all of you try to evaluate this. 2x e to the power y dy dx dz. If your steps are correct, you should end up with the same answer. So please try to do that. Like take 4 minutes, 5 minutes to do that. The same. Okay, good. So what about if we integrate over Q 1 dV? Just keep the same setting, but we will remove the quantity inside and replace it by 1. So let us evaluate this. And you know, what's this? It's like a box, right? From 1 to 2, x from 1 to 2. X from 1 to 2, and y from 0 to 1. We know the volume of such solid from 1 to 2. So this is 1 unit. Y from 0 to 1. Y from 0 to 1. So again, it's 1 unit. Z from 0 to pi. From 0 to pi, it's pi unit. So the final answer should be what? Should be the volume of this solid. The volume of this solid is 1 times pi. So let us check that. 1 times 1, which is pi unit cube. So let us check this. If you replace 2x e to the power y sine z with 1, what will happen? So first, to start with dz, z from 0 to pi, then dy from 0 to 1, and the final integration from 1 to 2. So the antiderivative of 1 with respect to z is z from 0 to pi. If you do that, this is pi minus 0. And you have to 2, and from 0 to 1, 1 dy dx. Now integrate the one inside, then this one. The antiderivative of 1 dy is y from 0 to 1. From 0 to 1, this is 1 minus 0, which is 1. So pi times 1, the remaining, the integration from 0 to 1, 1 dx. And the antiderivative of 1 with respect to x is x. X from 0 to 1, this is again is 1. So the final answer is pi. So yes, we have the same answers. ليش يطلع واحد؟ فاطمة أي واحد منهم؟ Integration of 1 from 0 to, from 1 to 2, 1 dx. 1 is x from 1 to 2. Replace x with 2, replace x with 1. The final answer is 1. Of course, we have outside pi. Ah, okay. Fatima, we replaced what's inside by 1. I'm not talking about the same example. We replaced all of these by 1. I'm saying if we want to evaluate the volume of a Q, if we want to evaluate, this is kind of part 1, evaluate this triple integral. Part 2, find the volume of Q. So how to find the volume for Q? The volume of Q is what? Triple integration over Q, 1 dV. So you integrate from what? From 1 to 2, from 0 to 1, from 0 to pi, 1 dz, dy, dx. Okay, so this is part 2. Part 1, yes, this is something different, yes. Part 1, if you change the order, if you do anything, your answer should be what? 6 times e minus 1. Clear, Fatima? If I'm asking about volume, okay? All right, so evaluate this triple integration, 2x minus plus y minus z over a rectangular box defined by x between 0 and 2, y from minus 2 to 2, z from 0 to 2. So we will evaluate this over q. So what we need to do in this case, from 0 to 2, from minus 2 to 2, from 0 to 2, 2x plus y minus z, dz, dy, dx. So first, we need what to evaluate the inner integral with respect to z. So let us take the first integral from 0 to 2, 2x plus y minus z, dz. Yes, but let us first distribute from 0 to 2 over the plus and minus. So from 0 to 2, 2x dz plus from 0 to 2, y dz minus integral from 0 to 2, z dz. Now, for the first term, this is constant. 2x is constant. So you need to factor it out. And the integral of dz is z from 0 to 2. The same here. You need to factor y outside. The antiderivative of 1 is z from 0 to 2. The last one, z is not constant. The antiderivative of z is z squared over 2 from 0 to 2. So 2 minus 0, 2, 4x. 2 minus 0 is 2, 2y. And 4 divided by 2 minus 2. So this is the integral for what? The whole integral is 4x plus 2y minus 2. Now you need to integrate from 0 to 2, from minus 2 to 2, 4x plus 2y minus 2. For x plus 2y minus 2 over the limits of y and x. And you will do the same. You'll take the integral inside. Since we have plus and minus, just distribute. Integration is dy, so this is constant. Outside, the antiderivative of y of 1 dy is y. From minus 2 to 2. Plus. Now here, y is not a constant. The antiderivative of y is y squared over 2. 2 with 2 eliminated, so y squared. And the final integration, the antiderivative of 2 to y is 2y. So the final answer is 4x. 2 minus minus 2, which is 4. Y squared, 4 minus 4, which is 0. 2 minus minus 2, which is 4. So the final answer is 16x minus 8. So the whole integral, this integral is 16x minus 8. And now you can finish this. This is calculus 1. 16x squared over 2, so 8x squared minus 8x from 0 to 2. 8 times 4, 32, minus 16, which is 16. This is the final answer. I like what we did before test 2, and it's similar to the question in test 2. And here we go. There's another example for what? For the same principle, dealing with what? Tetrahedron. So we need to evaluate triple integration of what? Of 6xy dv, where Q is the tetrahedron bounded by, in the first octant, 2x plus y plus z equals to 4 in the first octant. We learned how to sketch this plane. We find the intersection with x-axis by replacing y and z with zeros. So 2x equals to 4. The intersection with x-axis is 2. Now the intersection with y-axis, x 0 and z 0. X 0 and z 0, so y equals 4. the intersection with the z-axis, x equals 0 and y equals 0. If you replace x with 0 and y with 0, z will be 4. Yes, z is 4. So this is the shape of the tetrahedron. Just what trying them. Now, when you sit inside this tetrahedron, if you look down, if you are sitting here, if you look down, you will see what? You will see the xy plane. So this is the lower limit for z. This is the lower limit for z. At this plane, z is 0. Of course, we are in the xy plane, so z is 0. Now, if you look up, if you are sitting here and looking up, you will see what the surface, the plane. In this case, z will be what? Will be 4 minus y minus 2x. So these are the limits between 0 and 4 minus y minus 2x. Now we need the limits for what? The limits for y and x. As we said before the test, if you want the limits for x and y, you need, yes, the limits for y and x, you need to see what's the region, what's the projection of this solid on the xy plane. The projection on xy plane is this area, this triangular area. How to find this area? Also, we mentioned that you have to what? To replace z with 0. Why? I mean, we are in the xy plane, so z must be 0. If you replace z with 0, we'll end up with this triangular region. Now you have the freedom to what to choose between dy dx or dx dy. Depends on you. So this line is 2x plus y equals to 4. Okay, if you choose dy dx, y at this point is 0. And the upper limit, you have to solve this equation for y. Yes, exactly, Fatima. Thank you. 4 minus 2x. Now, what are the limits for x? The limit for x start, of course, at x-axis toward what? Toward this point. So x is between 0 and 2. Exactly. So this is what we want to do. We need to integrate 6xy using these limits. And of course, we start with the first integral. Integral from 0 to 4 minus y minus 2x. 6xy dz. Now, since we're dealing with dz, this is constant. So put it out. And the antiderivative of dz is z. Thank you, Fatma. From 0 to 4 minus y minus 2x. So 6xy times 4 minus y minus 2x. This is the final. So you cancel this integration, the one in this square, and replace it by 6xy times 4 minus y minus 2x. Okay, then we have integral from 0 to 2, from 0 to 4 minus 2x, 6xy times 4 minus y minus 2x, dy dx. You need to evaluate the second integration right now. So just distribute 24xy minus 6xy squared minus 12x squared y dy. So you need the antiderivative for this, and for this. First integral is what? 24x times y squared over 2. From 0 to 4 minus 2x. Minus 6x. Y squared is y cubed over 3. From 0 to 4 minus 2x. Minus 12x squared. The antiderivative of y is y squared over 2. From 0 to 4 minus 2x. So 12x times 4 minus 2x squared minus 2x times 4 minus 2x but cube minus 12x squared, no, 6x squared. 6x squared times 4 minus 2x squared. Now you have 4 minus 2x squared, a common factor. And also you have what? 2x, a common factor. 12x, 2x, 6x squared, also 2x. So what's remaining? Remaining 6 minus 2x is out, so 4 minus 2x. And 4 minus x squared outside, 2x is outside, so minus 3x. So 6 minus 4 plus 2x minus 3x. So this is what? This is 2 minus x. The whole thing is 2 minus x. 4 minus 2x, the whole thing squared, times 2x. Integrate from 0 to 2. So the final, maybe not, because we have another simplification. So we have this 4 minus 2x squared times 2x times 2 minus x. Now also we have 2 as a common factor here. 2 as a common factor. So 4 minus x squared times 2x times 2 minus x. So the final answer is 8x times 2 minus x cubed. This is the final answer, 0 to 2. So which technique do we need to use to find this integral? I mean, you have product of two functions inside the integral. Yes, clearly, but yes, thank you, Fatma. So we need to integrate by parts. So 8x, the derivative of 8x is 8. The derivative of 8 is 0. 2 minus x cubed. Now we need to integrate this. 2 minus x to the power 4 over 4, but don't forget the sign. Two minus x to the power 5 over 20. Another minus, so it becomes what? Plus. So plus and minus. So minus 2x times 2 minus x to the power 4 from 0 to 2. And plus 8 over 20, 2 minus x to the power 5 from 0 to 2. This is 0 plus 2 minus 2 also 0 minus 8 over 20 times 32. Thank you, Fatima. 64 over 5 minus 64 over 5. Of course, don't forget that we are not evaluating, thank you, Sheikha. We're not evaluating what? A volume in this case. Y, inside we have 6xy. It's looking like what? We are evaluating some kind of what? Kind of something like that. But it's not what? It's not a volume. Okay, after the break, we will what? Evaluate of this tetrahedron using what? Triple integration. Inshallah. Okay, so let us take an example to find what the volume of using triple integration. Okay, so now if you sketch this tetrahedron, Z, X, and Y. So if you intersect the x-axis, Y in this case is 0 and Z is 0, so X is 1. If you intersect with y-axis X is 0 and Z 0, so Y is 4. If you intersect with the z-axis X 0 and Y 0, so Z is also 4. Thank you, Fatima. Talking about this solid. So in order to find the volume of this solid, we need to triple integrate over what? Over Q, 1 dV. So now what are the limits for what? For Z, the lower limit is this region. If you sit inside this tetrahedron, if you look down, you see this region. If you look up, so if you draw a line, horizontal line, the one down will be at the xy plane, z0. The upper limit will be at this surface. The surface is what? Represented by this plane. So Z in this case is 4 minus 4x minus y. So these are the limits for Z. Z between 0 and 4 minus 4x minus y. Now, what are the limits for what? For y and x. For y and x, we have this region. So this region represented by what? By, yes. But what's the equation for this region? Triangular region again, represented by x-axis, y-axis, and by the line when z equals 0. When z equals 0, 4x plus y equals to 4. Intersect x at 1, intersect y at 4. So this is the region that we're talking about. And yes, as Fatima said, this is the line This line is 4 minus 4x. Y equals to 4 minus 4x. So y between 0 and 4 minus 4x. So from 0 to 4 minus 4x minus y, 1 dz, dy, dx. Now dy between 0 and 4 minus 4x. And the last one between 0 and 1. X between 0 and 1. Start with the first integration. So the antiderivative for 1 is z from 0 to 4 minus 4x minus y. So we have double integration from 0 to 1, from 0 minus 4x, for what? For 4 minus 4x minus z minus y dy dx. Now dy, this is constant. So as Fatima said, we multiply it by y. This is again is constant. We multiply it by y. This is not constant. We integrate it as y squared over 2. So from 0 to 1, 4y minus 4xy minus y squared over 2. From 0 to 4 minus 4x dx. So from 0 to 1. Now replace each y with 4 minus 4x. Of course, 0, 0. So 4 times 4 minus 4x. Four x times 4 minus 4x minus 4 minus 4x squared over 2. The whole thing dx. And factor out what? 4 minus 4x. Factor out 4 minus 4x. From 0 to 1. If you factor out 4 minus 4x, the first term is 4 minus 4x. Minus 4x minus 4 minus 4x, one outside and one will stay inside. Again, factor 4 minus 4x outside. So 4 minus 4x, the whole thing squared times 1 minus half, 1 minus half dx. So the final answer is half integration from 0 to 1, 4 minus 4x, the whole thing squared dx. Now you can integrate it using integration by substitution or apply the rule that we just said. It's a power rule, the same like power rule, but don't forget to divide by a. Ax plus b, power n is ax plus b to the power n plus 1 divided by n plus 1. This is a power rule, but don't forget to divide by a plus c. So half 4 minus 4x to the power 3 over 3, but multiplied by minus 4 from 0 to 1. If you substitute 0, if you substitute 0, 4 to the power 3 divided by 4 times, 3 times minus 4. So plus 4 squared so 8 over 3. 8 over 3 is the final answer. Plus, Fatma. We have a minus, and from integration is minus again. And don't forget, we talking about volume. And it coincides with what with the rule, which says 1/3 times the area of the base times tetrahedron. This is the volume. The volume is 1/3 times the area of the base times what the height. 1/3, the area of the base is a triangle. 1/2 times the base is 1. The height is 3. The height is 4. I think this is 4, not 3. Yes. So 16 divided by 2 is 8/3. This is our answer. Okay, let us also try to find a volume for find the volume of the solid bounded by say z equal x squared plus y squared paraboloid, and another paraboloid z equals to 2 minus x squared minus y squared. So we have a paraboloid from above and paraboloid from what? From now, this is the first paraboloid. The second one is a paraboloid. It's 2 minus x squared plus y squared. So the same paraboloid, but first you need to flip it down. Yes, thank you, Fatima. And pull it out, pull it up 2 units. So something like that. You have to So this is the solid that we're talking about. So now the limits for Z is clear. The limits for Z is clear. I mean, if you draw a vertical line, Z from below will be at the first paraboloid. From above, it will be on the second paraboloid. So clear. Now, what are the limits for x and y? So Z between x squared plus y squared, and between 2 minus x squared plus y squared. This is the limits for Z. Now, what are the limits for what? For x and y. Now, to have an idea what I'm talking about, imagine that you are sitting here and you're looking down, or you are sitting here, you're looking up. What's the common area between these what? Between these curves, these surfaces. In other words, what's the projection of this solid on XY plane? see, you'll have this area. How did I know that it's a circle? This surface is what a common, it's the intersection between what? Between the two. This area is an intersection of the two surfaces. So if you try to intersect this surface with this surface, to solve what? Z equal to Z. 2 minus x squared minus y squared equals to x squared plus y squared. Solve this. 2 equals to 2x squared plus 2y squared. Excellent, Fatima. So 1 equals to x squared plus y squared. So it's a circle. It's a full circle. Yes, it is a full circle. So this conclusion coincides with this. So you have to double integrate. When you talk about x and y, you have to take the limits a full circle. You have a full circle. And as Fatima said, we need to use polar coordinates in this case. We have to use what? Polar coordinates. So let us first start with the volume. The volume is integrate 1 dz dy dx. So let us evaluate dz first. Then change everything to polar. Now the antiderivative of 1 is what? Is z from 2 minus x squared minus x squared plus y squared. Now our R, you need to apply what? You need to use polar coordinates. Why? The region is a circle, and the quantity inside the integral is too easy if you use polar. X squared plus y squared is only multiply the whole thing by R, dr d theta. The limits for R is very easy. This is a unit circle. R, so the radius is 1. And we have a full rotation. So from 0 to 2 pi to R minus 2R cube dr d theta. From 0 to 1. Minus 2r to the power 4 over 4. So 3 over 4 d theta. And the final answer is what? 3 pi over 2 unit cube. And inshallah, in the upcoming meeting on Sunday, we'll extend this. Mixing the rectangular coordinates with polar coordinates. This will lead us to something we call it what? Cylindrical coordinates. cylindrical coordinates. We have cylindrical coordinates means that we are using polar coordinates on the base, and on the height, we keep it as it. We keep it Z. But on the base, we use what? We use R and theta. So it's, I hope this is clear. So on the base, we don't use X and Y, we use R and theta, especially if the base has what? Has circles or portion of circles, something like that. We have to use what? Use R theta. And Z, we keep it as it. In the last step, in the last part of the course, we'll have a problem with the base and Z. For example, dealing with a sphere. A sphere is very difficult to deal with with cylindrical coordinates or rectangular coordinates. We'll move to another system of coordinates. We call it what? Spherical coordinates. Spherical coordinates. So inshallah, we'll cover this topic